Hi, I'm Dr. Ellie Jameson. I'm a lecturer of environmental virology at Bangor University.
I'm Rosie Williams. I'm a researcher at the Institute of Zoology in London, based at the Zoological Society of London.
Hello, Mark Fitzsimons. I'm a professor of environmental chemistry at the University of Plymouth.
Hello, I'm Thomaz Andrade. I work for Natural Resources Wales.
So the project idea, I started thinking about linking up the work that we do on wastewater and monitoring what's coming out of wastewater treatment plants and out of hospital wastewater and what the larger impact is on the environment. So I'm the research theme lead for One Health at Bangor University. So it's really important to think of not just health isolated and human health on its own, but how humans impact our environment and how these impacts on other animals and on the environment itself can also impact on human health as well. So I want to look more at what happens when this pollution goes out into the environment. So we've been very interested in looking at viruses, but also antimicrobial resistance. When it leaves wastewater treatment plants, what effect is it having on the environment? So what, as well as the microbes which are going out into the environment, what chemicals, what pharmaceuticals, where do they end up?
So Ellie and I had a few useful chats behind the scenes while we were trying to develop this project. And I think it's really important to find the right systems to look for these antimicrobial resistance and these pharmaceutical chemicals. And marine mammals are really useful for studying the sort of distribution of chemical pollutants and impacts, because they're considered sentinel species because they have this long lifespan and they're apex predators and they're distributed all around the UK coast. And we so happen to have a really useful, interesting data set within the UK. So we're sort of considered to be global leaders in this space in terms of building up tissue archives from marine mammals that have stranded around the UK coast. So it seemed like a really good fit. We've already got this really brilliant data set and tissue archive that we're potentially not utilizing well enough at the moment to be looking at the questions that Ellie discussed. So it seemed like a really good fit as part of this wider project to look at in marine mammals as well.
Well, I've been interested in the behavior of pharmaceuticals. I've mainly looked at it in the past in a mechanistic sense to try to understand how a pharmaceutical might behave from when it's released in sewage effluent to surface waters, and how persistent it will be. And interestingly, the pharmaceuticals are still regarded as an emerging contaminant, but there are no regulations in place, really, understandably, given the importance for human health. So the analytical capacity to measure pharmaceuticals at low levels has greatly increased in recent decades. So what could be measured 20 years ago is much different to what can be measured today. And I think having that tissue archive, sample archive that Rosie just mentioned is a really exciting opportunity to look at legacy samples using cutting edge technology.
So from Natural Resources Wales perspective, we are interested in understanding what are the wide range of contaminants that cause impact to the environment. So we have our standard program, which are these chemical substances in legislation that doesn't include pharmaceuticals. They have lots of legacy contaminants, heavy metals and other things, which is our own in-house technology of using passive samplers where we can see up to 3,000 compounds. A lot of them are pharmaceuticals. This is to try to see what are the new chemicals out there. All the time, the new substances being discharged into the environment. We're detecting hundreds of substances, and we're in the process of understanding how relevant are those detections, because now with the new technology, we can detect all those things. So as part of the process is to understand the impact and what it causes to different types of animals, and both in terms of toxicology, survival rates, and also for antimicrobial resistance. Normally have thought of antimicrobial resistance as an issue for humans, a public health concern, which it is. We do work with public health authorities on that. But then there's this new emerging area.
Ideally, what we're looking for in a candidate for this project is someone who's interested in all different aspects of the project. So everything from looking at the microbes to seeing how they interact with the chemicals to looking at the bigger picture, this overview of what's going on in the whole environment and in these marine mammals. So we really want a student we're not expecting them to have all the different skills, but very open to gaining skills across microbiology, chemistry, and to understand the policy of these systems as well. But we're really interested in someone who's very open to gaining these new skills and understanding what the whole picture is and linking these different parts together, because it's very much an interdisciplinary PhD, and we want them to have this oversight on the different areas, so they can really put this big puzzle together and find out what's going on in a whole system. So within the first year, there's a lot of getting to know the supervisors in the areas of the PhD to begin with. And we have these big data sets that are already collected. So this is going to be working with what data has been collected by Natural Resources Wales already from their environment, looking at what pharmaceuticals, particularly those antibiotics in that system, and see if we can see some commonalities, link-ups between antimicrobial resistance genes and also what antibiotics are in the system, and also getting to know what is in the marine mammal tissue bank to see if we have overlap in area. So bringing those commonalities together will help also identify what the gaps are for carrying out the field work in subsequent years.
So what we've got within this cetacean strandings data set is we've got records on sort of number of strandings, so over 18,000 strandings records, and then a smaller subset of that, we've got around 4,500 post-mortem reports with sort of accompanying diagnostics in terms of virology, bacteriology, cause of death, etc. And full reports of those with accompanying photographs. And then the sort of next level down, again, we've got around 1,300 animals which we've carried out full toxicological analysis on, and that data set spans 30 years. So that's pretty good in terms of number of samples that have tox analysis, because it's pretty expensive to run. So if you compare that to sort of other long-term monitoring programs, it's a pretty good amount of samples in there.
But there's also data on fish, data, ecological data, and so on. And there's also the work being done with the Welsh Government, Welsh Water, and Bangor University, Cardiff University on what's in the wastewater effluent coming out. It's a very rich data set that could be incorporated as well.
Well, I think the first year will be focused on interrogating databases and getting to know the team and the context. But there is the possibility of a visit down to Plymouth to familiarise the student with the equipment that we use and to build their confidence up in that way.
I'm based at an academic institute at Bangor University, but obviously there's a wide range of careers out there. And like Thomas was mentioning before, we're part of this this big Welsh Government consortium who are looking at wastewater-based epidemiology across Wales. So we have a lot of different partners who we work with. So the opportunity is there to speak to other people in different careers, so they could go into academia, they could go beyond academia into policy, and we do link up with a lot of different companies and different resources as well. So I think it's quite open what career somebody could go into from this PhD. There are a lot of opportunities. There's a lot of different biotech companies who are out there as well. So as well as Welsh Government, Natural Resource Wales, we've linked up with other companies, water companies.
I think the multidisciplinary aspect of the project is such a really exciting aspect, and the whole issue of pharmaceuticals in the environment is very new. It's emerging, and it will be a major issue for I would say decades to come. So I think the student would have a lot of options in terms of opportunities to carry out further research or become involved in the regulatory and policy side of things to look at how society is going to react to this issue.
And also, I just echo Mark's point around how this is a really sort of priority research area. If you look at the types of projects that are being given money right now across the world, antimicrobial resistance is huge. So I think that's a real strength too for this project.
But I think as a partner coming from the industry side or the practitioner side, what we really want from this is that the outcome of the project is something that will directly inform policy and decisions for managing the environment. So this is a really great opportunity for students and for us as well to help preparing the future generations of scientists and policymakers in this field.
So I'm very happy to welcome queries and questions from anyone who's interested in applying for this PhD. So I'm happy for people to contact me at my email address at Bangor, which is e.jameson@bangor.ac.uk.